have some sort of matrix, like how big do we want the objects in our game. So I'm going to call this unit size, and it'll make more sense when we actually create a visible game panel. But for now, let's just type in static final int unit size. So how big do we want the objects in this game? And then we'll want to calculate how many objects we can actually fit on the screen. So static final int, and we'll call this game underscore units. And what we'll do is set this equal to screen underscore width times screen underscore height, and then just divide this by the size of the units, so unit underscore size. And then let's create a delay for our timer that we're going to implement later. So static final int delay. And when I tested this, 75 was fairly quick. So the higher the number for your delay, the slower the game is, and vice versa. So for this next part, we're going to create two arrays, an array called X and another called Y. These arrays are going to hold all of the coordinates for all of the body parts of our snake, including the head of the snake. So let's create two arrays. Final int X equals new int, and for the size of this array, I'm just going to set this to whatever our game units is, because the snake isn't really going to be bigger than the game itself. And then let's create another array called Y. So this array is going to hold all of the X coordinates of the body parts, including the head of our snake, and this one is going to hold all of the Y coordinates. And And let's set the initial amount of body parts we want for the snake. So int body parts, and maybe let's set this to 6. So we'll begin with 6 body parts on the snake. And let's declare an integer called apples eaten. And this will initially be 0. Int apple x. This will be the x coordinate of where the apple is located, and it's going to appear randomly each time that the snake eats an apple. And int apple y for the y positioning. Then we'll want a direction. We can easily do this with a character value. So char direction, and we can initialize this to something or set this to something. So let's have the snake begin going right when we start the game. So we'll have R for right, L for left, U for up, or D for down. So I'm just going to have the snake begin by going right. And then we'll want a Boolean value called running, and we'll set this to false to begin with. Let's declare a timer called timer, and an instance of the random class called random. And that is everything that we need to declare before the constructor. So let's go to the constructor. Next, and the first thing we'll do is finish creating this instance of the random class. So random equals new random, and we're going to set the preferred size for this game panel. So this dot set preferred size, and we're going to pass in a dimension, but we'll just say new dimension. And then within the parentheses of new dimension, we can pass in some arguments such as the screen width and the screen height. So screen width and screen height. Let's set the background color. So this dot set background, let's say black, color dot black. And we'll want to set the focusability. So this dot set focusable true. We're going to add a key listener. So this dot add key listener, and we're going to create a new my key adapter. All right, so when we finish constructing this game panel, we're going to call the start game method. So start game, and we'll head to the start game method next. I forgot to add a method, so let's do that. I'll add this after the next. I forgot to add a method, so let's do that. I'll add this after the draw method, so we'll want to populate the game with an apple so we can actually score a point. So let's create a method called public void, and we'll call this new apple. All right, so that should be all the methods that we need, but yeah, I did forget about this one. So when we start this game, what we're going to do first is call the new apple method to create a new apple on the screen for us. Let's take our Boolean called running and set this equal to true because it's false to begin with. And then we'll finish creating this instance of our timer. So timer equals new timer. We're going to pass in our delay value. So this will dictate how fast the game is running. So 75 play value, so this will dictate how fast the game is running. So 75 is somewhat brisk, and we're going to pass in this because we're using the action listener interface. And then lastly, we're just going to take our timer and use the start function. And that is it for the start game method. So let's go to paint component. And we're going to type in super.paint component and pass in G. So there's one thing I want to explain to you guys. Let's just run this once. So here are the the dimensions for our game. One thing I want to explain to you. You guys, let's just run this once. So here are the dimensions for our game. It's 600 by 600, and each item in this game is going to have a dimension or dimensions of 25 pixels for the width and the height. So that's a little difficult to actually see on this game. So what I'm going to do is turn this into a matrix or grid just to help us us visualize things. So this part is completely optional, but I'm just going to turn this into a grid so it's easier for us to see things. So I'm just going to create a for loop within the draw method for int I equals 0, and I'm going to continue this as long as I is less than our screen underscore height divided by the unit underscore size. I'm basically going to be using this for loop to draw lines across our game panel so it becomes some sort of grid. And then I'm going to increment I by 1 each time. So we're going to draw lines across the x-axis and then y-axis. So we'll use the g.drawLine method. And we're going to pass in some starting coordinates and ending coordinates. So since we have this in a for loop, we're going to utilize this index of I. So for the x position, I times unit underscore size. For y2, we're going to set this to 0. For x2, we're going to type I times unit underscore size, and then y2, the screen height. So let's take a look at this. So here are all of the spaces along the x-axis. So let's take a look at this. So here are all of the spaces along the x-axis. So let's do the same thing for the y-axis. So it's a similar process. G.drawLine. But we're going to change a few things around. So for this first argument, this will be 0. Then I times unit size for the second. The third is going to be screen underscore width, and the fourth argument is I times unit underscore size. So let's take a look. So here is our grid. So each item in this game is going to take up one of these spaces. So if we were to increase increase the unit size, let's say 50, well, all of the items in this game are going to be larger then. So that's what the purpose of the unit size is. How big do we want the items in this game? So for now, I'm just going to keep in this for loop just to help us develop this game, but by the end, we'll probably take out this grid, or you can keep it in, doesn't matter. So let's work on generating the coordinates of the apple within the new apple method. The purpose of the new apple method is to generate the coordinates of a new. So let's work on generating the coordinates of the apple within the new apple method. The purpose of the new apple method is to generate the coordinates of a new apple for us whenever this method is called. So anytime we begin the game or score a point or eat an apple, basically. So let's take our variable apple x. So this is the x coordinate of our apple equals random dot next int. So we're going to have this apple appear someplace along the x-axis. So the range is going to be our screen underscore width. However, we're going to divide this by the unit underscore size. So it's as if we're going to get one of these positions. So this will be 1, 2, 3, get one of these positions. So this will be 1, 2, 3, 4, and then we'll just continue on like that. But let's also cast this as an integer just to be safe so it doesn't break this program. And then we're going to multiply this at the end by our unit underscore size. And then let's do the same thing for y. So apple y equals random.nextInt. Then we're casting screen underscore height this time divided by unit size. And then after this is complete, multiply this by the unit size because we want this apple to be placed evenly within one of these item spots, I would say. All right, so then let's draw this apple on the screen, and it's going to appear randomly every time we actually draw this. So let's head back to the draw method, and we're going to draw the apple. So first, let's set the color. So g dot set color, and we'll set this to red. I guess it could also be like a green apple too, but let's set it to red for now because I want the snake to be green. So g dot set color, and then let's use g dot fill oval for a circle. So we're going to pass in the coordinates apple x, apple y, the width and the height, and we're going to pass in the unit size. So this is how large the apple is. So let's run this. So here's that apple. It should fit within the apple is. So let's run this. So here's that apple. It should fit within one of these grid spaces and be lined up perfectly within it. And every time we run this, it will most likely appear in a different spot. So we know that the apple is working then. And if you were to go back and change the item size, let's say back to 50, well, all of the grid spaces will be larger. Same thing with the items, such as the apple and the body parts of the snake as well. But I'll just keep this at 25, but I wanted a visual demonstration of how the unit size kind of plays into this program. So let's work on creating the move method of this game panel class. So we're going to be moving the snake with this method. First, we're going to create a for loop to iterate through all the body parts of the snake. So we'll have int I for index and set this equal to the amount of body parts that we have for our snake. So I equals body parts. We'll continue this as long as I is greater than 0, and then we'll decrement I by 1 after each iteration of this for loop. So what we're going to be doing is actually shifting the body parts of our snake around. So we'll take x, our array x, at index I, and we're going to set this equal to our array x at index I minus 1. So basically, we're shifting all the coordinates in this array over by one spot, basically. And let's do the same thing for y. So y at index I equals y at index I minus 1. So let's also create a switch that will change the direction of where our snake is headed. So we'll create a switch, and we're going to examine our direction variable, and direction is a character value, so we'll have this store the letter R for right, L for left, U for up, and D for down. So we're going to create a case for each of these possible directions. So we'll have a case U for up, and what we're going to do for this case is take our array y at index 0. This is the y coordinate of the head of our snake, and we're going to set this to y0 minus our unit underscore size. So it's going to go to the next position, and then we will break. And then let's do the same for each of the cases and make a few changes. So case D will equal y at index 0 equals y at index 0. 0 plus the unit size. And let's create one for L for left. So we're going to take our X array at index 0 equals our array X at index 0 minus the unit size. So this will make us go to the left. And then case R for right. X at 0 equals X at 0 plus the unit size. And that is it for the X at 0 plus the unit size. And that is it for the move method. So we just need to draw the snake. We need to draw the head and we need to draw the body. So let's go to our draw method and fill in these things. So let's draw the head of the snake and the body. So we're going to create a for loop to iterate through all of the body parts of the snake. So for int I, the index, and we'll set this equal to 0. We'll continue this for loop as long as I is less than the amount of body parts that we have, and then we're going to increment our index by 1 after each iteration. So if I is equal to 0, then we're dealing with the head of our snake. We can either draw this the same color or we can draw it a different color. So if I is equal to 0, let's take G and set the color to color.green. And then let's take G and use the fill rect for rectangle method. And we're going to set x to our array x at index I, and then our coordinate y will be our array y at index I as well, and the width and the height are going to be our unit size. So I'm going to copy this, and we're going to change width and height to unit size. So if I does not equal 0, we're dealing with the body of our snake. So else, let's take G again and set the color for the body, but I'll pick a different shade of green. So instead of saying color.green or so, I'll just say new color and type in an RGB value. So I already picked one out. One that was decent was 45 and 180 and 0. And then we just need to use g.fillRect. And we can keep that the same. So let's run this and take a look at what we have so far here. So here is the head of our snake, but we cannot yet see the body. So we'll actually need to call the move function. So we're actually going to call that within the, where is it? The action performed method. So we're going to fill in a few things within this method next. So we're going to check if our game is running. So if it is running, this is going to be true. The first thing we'll want to do is move our snake. And then we're going to check to see if we ran into the apple. So check apple. Then check collisions. And if this game is no longer running, we're going to call the repaint method. Okay, let's try this. So here's our snake. It's actually moving pretty fast, but it's just going to go off the screen. So let's set up the collisions to actually move. Okay. Okay, let's try this. So here's our snake. It's actually actually moving pretty fast, but it's just going to go off the screen. So let's set up the collisions now, actually moving pretty fast. Okay, let's call the repaint method. Okay, let's